In this video, we're going to talk about the SI unit prefixes and show you how to do some calculations involving these prefixes. The SI unit prefixes, sometimes called metric prefixes, and these precede an SI unit, such as a gram, meter, second, liter, etc., etc. And these indicate some power of 10 multiple or fraction of that SI unit. And each prefix is assigned a unique symbol and abbreviation. So let's take a look at some of these. Here's a list. Now this is not a complete list, but these are the ones you want to be familiar with. Let's take a look at one of them, for example. The prefix giga is abbreviated with a capital G, and the prefix indicates a billion. Written in scientific notation, it would be 1 times 10 to the 9th. And so if you put the prefix giga in front of an SI unit, like a meter, 1 gigameter, since a giga indicates a billion, 1 gigameter is a billion meters. Let's take a look at another, a kilo. The prefix kilo is abbreviated with a smaller, a lowercase k, and that prefix indicates 1,000 of that particular SI unit. So 1 kilometer, the prefix kilo meaning 1,000, 1 kilometer is equal to 1,000 meters. Now here we're using meter as an example, but this could be a 1 kilogram would be 1,000 grams, 1 kilosecond would be 1,000 seconds, etc. So we're just using the SI unit meter as an example. Now we also have some SI unit prefixes that indicate fractions. Let's take a look at a couple of these. The prefix centi, which is abbreviated with a lowercase c, is 100th of that SI unit. We could express it as a fraction, 100th, but more correctly, it's going to be expressed as a decimal. So 100th can be expressed as 0.01. In scientific notation, it would be 1 times 10 to the minus 2. So the prefix centi is 100th of something. So 1 centimeter would be 100th of a meter. So here you can see 100th of a meter is equal to 1 centimeter. Let's take a look at one other, a micro. Micro, the prefix micro is abbreviated with a Greek letter mu, looks like a fancy U. This indicates a millionth of some SI unit. Written in decimal form, you can see it would be 0.000001. And so that represents a millionth of something. So 1 micrometer would be a millionth of a meter. So you can see these prefixes, again, they just indicate some power of 10 multiple or fraction of a particular SI unit. Now, we can express these slightly different way. I tend not to like to deal with decimals. I like to deal with whole numbers. So we could express these decimals, these decimal prefixes, a different way. Let me show you a slightly different chart. Here you can see these big prefixes are the same, but the decimals, I've written them slightly different. Let's take a look at the centi. The prefix centi is 100th of something. So a centimeter is 100th of a meter, as we showed you just before. We could also express it a little different way. Instead of saying 1 centimeter is equal to a hundredth of a meter, as we did previously. Here you can see 1 centimeter is 100th of a meter. We could write it a little different way and say 1 meter is equal to 100 centimeters. Both of those are equally correct statements. So you can pick whichever you prefer. I prefer to do it like this because here you can see we don't have to use any decimals. We can just use whole numbers. Micro, again, a micro, the prefix micro is a millionth of some SI unit. And so we could say, as we did before, 1 micrometer is a millionth of a meter. Or, equally as correct, we could say 1 meter is a million micrometers. So it takes a million micrometers put together to equal 1 meter. So again, both of those are correct, and you can do whichever you prefer, but I prefer to use these. And I'll show you some of these, how we use these in just a minute. So take a couple of minutes and answer these questions. Okay, 1 millimeter is equal to how many? Excuse me, 1 milliliter is equal to how many liters? 1,000 grams is equal to 1 blank. 100 centigrams is equal to how many grams? And 1 megasecond is equal to blank seconds. Take a minute and answer those questions. Okay. So 1 milliliter is equal to a thousandth of a liter. 1,000 grams is equal to 1 kilogram. 100 centigrams is equal to 1 gram, and 1 megasecond is equal to a million seconds. So please take some time and become very familiar with these SI unit prefixes. Be aware of their definitions and their abbreviations. We use those a lot in chemistry. Now, one other thing about these SI unit prefixes, we can express them as equivalencies. So an equivalency would be something like this. 1 liter is equal to 1,000 milliliters, right? So that's true. We showed you that previously, that the prefix milli is 1,000. So 1 is a thousandth of something. And so 1 liter is 1,000 milliliters. So these two are equivalent to each other. And things that are equivalent to each other can be expressed like we have here, but they can also be expressed as fractions. 1 liter over 1,000 milliliters, or we could write 1,000 milliliters over 1 liter. All three of these are saying the same thing, that 1 liter is equal to 1,000 milliliters. We often, when we're working problems, we like to express our equivalencies as fractions, because then we can use a dimensional analysis approach to solve some mathematical problems. And I'll show you how to do that right now. So let's take a look at a problem that we might encounter in our class. You have a block of lead that has a mass of 3.45 grams. What is the mass of this block of lead in kilograms? So we're taking the same block of lead, but we're expressing the mass instead of in grams in kilograms. Now there's lots of different ways to solve these problems. I would strongly encourage you to take a very systematic approach to solving problems like this, or any type of problem. A systematic approach is where you basically apply the same approach to every similar type of problem. When you have an approach that works and you apply that same approach to each of these problems, your odds of getting it correct and your odds of getting it correct go up, and your odds of making a mistake go down. So let me show you how I would solve this problem using a systematic approach that can be applied to any of these SI unit prefix problems. And I would encourage you to take some time, even if you use a different method, take some time and try to see if this approach works for you. So the first thing I want to do is write down the number and the units that I want to start with. So my problem said I have a 3.45 block of lead that has 3.45 grams. So that's what I'm going to start with. So let's write that down. Okay. Next thing I want to do is I'm asked in the problem to convert from grams to kilograms. So the SI unit that I want to get rid of, I put on the bottom of this fraction, and the SI unit that I want to convert to goes on top. So I want to convert from grams to kilograms. So I put the gram on the bottom, kilogram on the top. Now, of course, this is not correct. We have to add some numbers in there. look and see which one is bigger, a kilogram or a gram. Okay? Well, a kilogram is bigger than a gram, so I put the number 1 with whichever unit, beside whichever unit is bigger. A kilogram is bigger than a gram. Okay? Now, the conversion factor, 1 kilogram is equal to 1,000 grams. So, and I have to know that. I have to be familiar with my SI unit prefixes. So I put the 1,000 on the bottom with the gram. Okay? Like I said before, I don't like to use the decimals. You can if you prefer, but using these whole numbers, again, allows me to use the systematic approach. So I put grams on bottom, kilograms on top. A kilogram is larger, so I put the 1 with the kilogram. And then 1 kilogram is equal to 1,000 grams. So the 1,000 goes on the bottom. Okay. Now I perform my math, and basically the grams, units of grams, cancel out, and I multiply 3.45 times 1 and divide by 1,000. I end up with units of kilograms, so my final answer would be 0.00345 kilograms. Always we want to put our units with a number. Don't ever not put down the proper units. So let's take a look at another problem, and hopefully this approach will become a little more clear. You have a liquid with a volume of 254 milliliters. What is this volume in liters? So again, I recognize that this problem, I'm just converting from one unit to another using my SI unit prefixes. So the first thing I would want to do would be to write down the number I'm given, 254, and the units, milliliters. Now the problem said I want to convert from milliliters to liters. So I want to convert from milliliters, so the milliliters goes on the bottom. I want to convert to liters, so the liters goes on the top of my fraction. Now I look and see which one is larger, a liter or a milliliter. Well, a liter is larger, so I put the number 1 by the liter. And now I look back, and what is the conversion between 1 liter and milliliters? 1 liter is equal to 1,000 milliliters. So here, again, if I put the 1 by the larger unit, then I don't have to ever use any decimals. This will be a number larger than 1. So it'll be 10, 1,000, a million, whatever. So now I have that. I can perform my math. The units of milliliters will cancel out. I'll end up with liters, which is what I want. So I'm basically dividing 254 by 1,000. My final answer would be 2.54 liters. Let's look at one other problem, and let's apply that same approach to this problem. You have a bar, and the length of this bar is 0.774 kilometers. What is the length of this bar in centimeters? Now this problem's a little different because I don't know a conversion directly between kilometers and centimeters. So I would approach this in 2 steps. Again, here I'm going from one SI unit prefix to another. I'm not going from an SI prefix to a base unit. So I have to do this in more than one step. At least that's the approach I like to take. What I'm going to do, I can convert my kilometers into meters because I know that conversion, and then I can convert meters into centimeters because I know that conversion. So I'm going to do this problem in 2 steps. But I want to use that same approach that I was telling you before. Okay. First thing I want to do is put down the number that I am given that I want to start with. 0.774 kilometers, that's the length of the bar. And my strategy told me that I want to convert that first into meters. So I'm going to put the unit I want to get rid of on the bottom and the unit I want to convert to on the top. Kilometers or kilometers goes on the bottom, meters goes on top. Put the number 1 by whichever is larger. In this case, a kilometer is larger than a meter, so I'm going to put the 1 by the kilometer. And my conversion between kilometers and meters tells me that 1 kilometer is equal to 1,000 meters. Okay. Now I'm going to do this all in one step, all in one problem. We now want to convert from meters to centimeters. So I want to get rid of meters, get out of meters, and get into centimeters. So meters goes on the bottom of my second fraction. Centimeters goes on top. Which is larger, a centimeter or a meter? Of course, a meter is, so I'm going to put the number 1 here. And now the centimeter gets a number that's going to be larger than 1. 1 meter is equal to 100 centimeters. I know that conversion. So now I have this, what we call a dimensional analysis problem set up. And I just have to cancel out my units. My kilometers cancel. My meters cancel. There should be a line through here. And I'll end up with centimeters as my final units. So I'm going to take 0.774 kilometers times 1,000, multiply that times 100, and I should get 77,400 centimeters. Excuse me. So again, as long as I take that same approach, I can do very large or small problems, but I like to use a very systematic approach. I hope that you'll take the time to give this a chance, and once you get comfortable with it, it'll work every time. So let's take a look at another problem. I'd like for you to work this one, and when you work this one, follow those same steps. Go step by step through those steps that we just showed you and see if you can come up with the correct answer here. Green light has a wavelength of 515 nanometers. What is this wavelength in meters? Take a few minutes and solve that problem. Okay. So what I would do is first write down the number that I'm given. Then I would put up a fraction beside it where I want to convert to meters, and I want to convert from nanometers. So meters goes on top, nanometers on the bottom. Meter is larger than a nanometer, so the meter gets the 1. And the conversion between a meter and a nanometer, 1 meter is equal to a billion, or 1 times 10 to the 9th nanometers. Now my nanometers will cancel, and I come up with 5.15 times 10 to the negative 7th meters. Let's try one more problem. A chemical reaction produces 0.000575 kiloliters of sulfuric acid. How many milliliters of sulfuric acid was produced? Take a few minutes and use that same approach to solve this problem. So the first thing I would notice in this problem is that I'm converting from one SI unit prefix, a kilo, to another SI unit prefix, a milli. So I'm converting from one prefix to another, not from a prefix to a base unit. Typically, when you see that, it's best to approach those in a two-step fashion, like we have here. First thing, let's follow our systematic approach. Write down the number that you're given and the units. I want to convert from kiloliters to liters, so kiloliters goes on the bottom, liters on the top. A kiloliter is larger, so I put the 1 in front of the larger. 1 kiloliter is equivalent to 1,000 liters, so 1,000 goes on top. That will get me from kiloliters into liters, but I want to convert that ultimately to milliliters. So I'm going to do another equivalency, another fraction, with liters on the bottom and milliliters on top, since I want to end up with milliliters. 1 liter is larger, so that gets the 1. The smaller unit, the milli, 1 liter is equal to 1,000 milliliters, so I put 1,000 with the milliliters. Now all I have to do is take 0.000575 times 1,000, multiply it times 1,000 again, check to see that my units cancel. Again, that way I know I have it set up correctly. And I end up with units of milliliters. 575 milliliters is equivalent to 0.000575 kiloliters. So be sure that when you solve any SI unit conversion, SI unit prefix conversion problem, I would encourage you to use this systematic approach. Always put down your units, and if you follow this step-by-step approach, a lot of times I found that it'll help avoid any confusion or error. So give it a shot.